Next topic is lines in three dimensions. So first is symmetrical form of the equation of line. So find the equation of line. Question is what? Find the equation of line passing through the point x1, y1, z1 and having direction cosines ELMN in symmetrical form. So we are given the point on the line and direction cosines of line, and we have to write equation of that line in symmetrical form. So point on the line and what the direction cosines ELMN or direction ratios ELMN are given. So let q x y z be any another point on the line, that is p x1 y1 z1 is one of the point given on the line, and let q be another point lies on the same line q x y z, coordinate are x y z. Then the direction cosine ratios of the line are what? X minus x1 comma y minus y1 z minus z1. So these are the direction ratios. If we know the 2 points on the line, then we can find the direction ratios of that line, and that are what? X minus x1, y minus y1, z minus z1. Okay, so these are the direction ratios of the line. So if we know the 2 points on the line, then we can write the direction ratios of the line like this. So we have x minus x1 by n is equal to y minus y1 by m is equal to z minus z1 divided by n. Because the direction ratios and direction cosines of line are in proportional. So what we have? X minus x1 by n, y minus y1 by m is equal to z minus z1 by n. And this is the equation of line in symmetrical form. That is, these are the direction ratios, and therefore the direction ratios and direction cosines are in proportional. So ELMN are the direction cosines of the line, and x minus x1, y minus y1, z minus z1 are direction ratios of the line. And so they are in proportional. So we have this x minus x1 by n is equal to y minus y1 by m is equal to z minus z1 by n. And this is the equation of line in symmetrical form. So find the equation of line in symmetrical form. This is the proof. That is, we have the equation of line in symmetrical form. So x minus x1. If we how we can write the equation of line in symmetrical form? If we know the direction, if we know the point on the any one point on the line and the direction cosines or direction ratios of the line, then we can write the equation of line as x minus x1 by l, y minus y1 by m, z minus z1 by l. This is the equation of line in symmetrical form. The equation of line passing through point x1, y1, z1 and having direction ratios ABC is again what? X minus x1 by a, y minus y1 by b, z minus z1 by c. Okay. So either the direction ratios or direction cosines of the line are given and one point on the given, then you can write the equation of line in symmetrical form. So in 12th standard, we know we learn the equation of line passing through 2 points. That is called 2-point form of the equation of line. So we can also write the equation of line in this 3 dimension if we know the 2 points on the line. So here the find the question is the example for 2 marks, that is find the equation of line passing through the point 2, minus 3, 4 and having direction ratios 1, 2, minus 3. And so the equation of line in the symmetrical form, that is the equation of line passing through this point and having direction ratios 1, 2, minus 3 is what? X minus 2, that is x minus x1 by a means 1, y minus plus 3 by 2 and z minus 4 divided by minus 3. So this is the equation of line passing through this point and having direction ratios this. So this is called 2-point form. Find the equation of line passing through the 2 points p x1 y1 z1 and q x2 y2 z2. That is, we know the 2 points on the line, and if we know the 2 points on the line, we can write the direction ratios of that line. So the direction ratios of the line PQ are x2 minus x1 comma y2 minus y1, z2 minus z1. So these are the direction ratios, and so we know one point on the line. Suppose p x1 y1 z1 is point on the line and consider as a point on line, and x2 minus x1, y2 minus y1, z2 minus z1 are direction ratios like ABC. These are the ABC direction ratios of the line PQ, and therefore the equation of line PQ is what? x minus x1 by x2 minus x1, that is a means what? Here a is x2 minus x1. Then y minus y1 like this, y minus y1 divided by b means what? Y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So this is the equation of line passing through 2 points: x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. So this is the equation of line. It's called 2-point form. So this is the equation of line. So next question is what? Find the equation of line passing through these 2 points. So write its answer. So answer is what? X minus 1 divided by 1 minus 2, minus minus plus 2. So write the question. Find the equation of line passing through the 2 points. This. So these points are x1, y1, z1, and this is x2, y2, and z2. And then answer is what? X minus x1 divided by x2 minus x1, that is minus 2 minus 1, minus 2 minus 1. Y minus y1, so y plus 2 divided by 3 minus minus plus 2. 3 minus minus plus 2. 3 plus 2. If it is minus 3, if it is minus 3, then write minus 3. So this point is minus 2, minus 3, minus 4. Minus 3, minus 2, right here minus 3 sign, 4. Then y minus 1 is plus 2 divided by minus 3 plus 2. Then z minus 3 divided by 4 minus 3. And so answer is what? X minus 1 divided by minus 3, y plus 2 divided by minus 1, z minus 3 divided by 1. And this is the equation of line passing through these 2 points. So this probability is very important, 95% probability. This is also important, that is write the equation of line passing through 2 points. Next question is find the equation of line of intersection of 2 planes. Okay, find the equation of line. This wording is in bracket, means either given, this is given in the problem or not given in the problem. That is find the equation of line. This is the equation of plane actually. X minus 2y plus 3z is equal to 4, and this is 2x minus 3y plus 4z is equal to 5 in symmetrical form. That is these equations are equation of planes. So after intersection of these 2 planes, we have the straight line, or we have the line of the intersection of 2 planes is line. And now we are given these 2 are the equation of planes. So what is the equation of line of intersection of these 2 planes? That is where to find the equation of line of intersection of these 2 planes. That is after intersection of these 2 planes, we have a line and we have to find the equation of that line in symmetrical form. And we know that if we have to write the equation of line in symmetrical form, then 1 point on the line is required, and the direction ratios or direction cosines of that line are required. So we will find the first point on the line. Now we will find in the first part of the example, we will find the point on the line. So how we can find the point on the line? Put z is equal to 0 in these 2 equations, equation number 1 and equation number 2. Suppose these 2 equations are equation number 1 and equation number 2. Then write next sentence. So first write the equation number, this is numbering as 1, this is the second, and then put z is equal to 0. So this is the procedure to obtain the point on the line. Put z is equal to 0. Therefore x minus 2y is equal to 4. We have this x minus 2y is equal to 4, and 2x plus 3 2x plus 3y plus 3y, 2x plus 3y, this 2x plus 3y is equal to 2x, it is minus sign, 2x minus 3y is equal to 5 after substituting z is equal to 0. Then solve these 2 equations for x and y. So that is multiply the equation 1 by 2, and then subtracting, we have what? Minus minus, this become plus. So this is minus y, and 8 minus 5 becomes 3. So y minus y is 3, means y is minus 3. Minus y is 3. So So after subtracting, we have, this is negative term, this is a positive term now, and this is negative term. So minus 4y plus 3y is minus y, right here minus 1. And it is not 30, it is 8 minus 5, that is 3. Don't write here 33. And then y is minus 3. And substitute y as minus 3 in this equation 1. So we have x as plus 2, x as minus 2, x as minus 2. So this is plus 6. After shifting to right, it is minus 6, then x is minus 2. And therefore the point on the line is what? Point on the line. So this equation x, this is my plus 6, okay. Then after shifting it, it is becomes minus 6. 4 minus 6 is what? 4 minus 6 is minus 2. So the point on the line is what? Minus 2, minus 3, 0, right? Minus 2, yeah, minus 2, because x is minus 2. So we have the point on the line is what? Minus 2, minus 3, 0, right? That minus 2, minus 3, 0. Then second part of the answer of the example is what? Now we have to find the direction ratios of the line. So how we can find the direction ratios? The equation 1 and 2 becomes, by substituting d is equal to 0, constant, substitute constant term as a 0. So we get x minus 2y plus 3z is equal to 0, and then 2x minus 3y, 2x minus 3y plus 4z is equal to 0. So substitute d constant term as a 0 in the equation of two planes. Then solve by Cramer's rule. So what is the Cramer's rule? X determinant, x is plus, y is minus, z is plus. The plus minus sign. Okay, like the determinant. And then write divide by x as a determinant. Cancel the first row, x terms, and then what do we have? Minus 2, 3, right here minus 2, 3, and the determinant of minus 3, 4, the second row. Then minus y, cancel this row, column, that column of y. Then 1, 3, determinant of 1, 3, and the second row is 2, 4. And z divided by, cancel this row, column. Then 1 minus 2, determinant 1 minus 2, 2 minus 3. And then x divided by, this is minus 8 plus 9. Then minus y divided by 4 minus 6. And z divided by minus 3 plus 4. And then x by 1, y by 2, y by minus 2, right here. Okay, minus 2, minus become plus. Yes, it is correct that y divided by 2, z divided by 1. And so these 1, 2 and 1 are what? Direction ratios of the line. So we have the point on the line. This is the point on the line, minus 2, minus 3, 0. And we have the direction ratios of the line, that is the values of ABC, 1, 2, 1. And therefore the required equation of line is x minus plus 2, that is x plus 2 divided by 1 as A, direction ratios. Then y minus plus 3 divided by 2, y plus 3 by 2. Then z minus 0 divided by 1, z minus 0 divided by 1, that is z by 1. So this is the equation of the required line, the required equation of the line, okay, so in symmetrical form. So if we are given equation of two planes, and if I have to find the equation of line of intersection of these two planes, then follow this procedure. That is, first obtain the point on the line by substituting z is equal to 0, and then obtain the direction ratios of the line by substituting constant term as 0, and solving these two equations by Cramer's rules. We have the direction ratios, and then write the equation of line in symmetrical form. So next example, find the point from intersection of line x plus 1 by 1, y plus 3 by 3, z minus 2 divided by minus 2 with the plane 3x plus 4y plus 5z plus 5z is equal to 5. The equation of line is what? 5x, 3x plus 4y plus 5z is equal to 5 is the equation. And the equation of line is what? X plus 1 by 1, y plus 3 by 3, z minus 2 divided by minus 2. Now we have to find the point of intersection of line and plane. So we know that the equation of line touches the plane in one point. In one point. So uh, uh, intersect the line, intersect the plane in only one point. While if we intersect the line and sphere, then line intersect the sphere in one point or 2 points. There are 2 points of line of intersection with the sphere, but the line intersect with the plane in only one point. So how you can find the point of intersection of line and plane? So the equation of line is in this form, symmetrical form: x plus 1 by 1, y plus 3 divided by 3, z minus 2 divided by minus 2. Suppose it is equal to r, and then consider the first ratio and this value r, that is x plus 1 by x plus 1 by 1 is equal to r. Therefore x is what? X is what? X plus 1 is equal to r, and therefore x is what? Minus 1 plus r. Similarly, y plus 3 by 3 is equal to r gives y plus 3 is equal to 3r, y is equal to minus 3 plus 3r, and z minus 2 by minus 2 is equal to r. Therefore we have z minus 2 is equal to minus 2r. Therefore z is equal to plus 2. After shifting these two to right side, we have plus 2 plus 2 minus 2r. So the coordinate of any, or is called general point on the line r. These are the coordinate of any point on the line, this line. So any point of the on the line this uh, has the coordinate of this type: minus 1 plus r, minus 3 plus 3r, comma 2 minus 2r. Right, in round bracket, write this as the x coordinate, y coordinate, and z coordinate. So as per the position of the point on the line, this r changes. This r changes as per the position of the point. So if we take the different values of r, we get the different points on the line. So any point on the line or general point on the line has the coordinate of this type. Okay, and if this, and we have to find the point on the line as well as the point on the plane, because we have to find the point of intersection of line with plane. So suppose this point lies on the plane, that therefore what we have, if this point on the line lies on the plane, then we have this point satisfies the equation of plane. So equation of plane is 5x plus 4y plus 5z is equal to 5. Substitute x, y, z as this: minus 1 plus r, minus 3 plus 3r, and then 5 2 minus 2r is equal to 5 in the equation of plane. And simplify, right? Multiply by 3, multiply by 4, multiply by 5, and addition of r terms and constant terms. So we have minus 5 plus 5r is equal to 5. So 5r is equal to 5 plus 5, and so 5r is equal to 10, and therefore r is 10 by 5, that is r is 2. Substitute this value of r in this equation. So minus, we have the point of intersection is what? Minus 1 plus 2 means, minus 1 plus 2 means 1. Then minus 3 plus 6, minus 3 plus 6, comma 2 minus 4, 2 minus 4, and therefore we have the point of intersection is what? 1 minus 3, not plus 3, plus 3, minus 3 plus 6 is 3, 1 3 and minus 2. This 2 minus 4 is minus 2. So this is the point of intersection of line and plane. So the distance of point from a line is the next point. We will see this point in the next lecture.